This is Don Larson. We're ready to get started with our webinar today on 3D interactive technical illustrations. Thank you all for joining us. Before we get into the main part of our presentation, just a quick review of the webinar housekeeping rules. If you experience any problems, please use the questions box in the control panel. All attendees will be muted for the duration of the webinar, but we will have we'll turn that back on at the end so we can have a Q&A. Computer audio is recommended for your audio. There are some associated materials or handouts that are in the little handout section. These are PDFs or images you could just drag and drop to your desktop. Post your questions at any time during the webinar using the question panel. We'll be monitoring that, and then we'll go through that at the end of the webinar. For those of you who don't know or are not familiar with Larson Software Technology, we're based in Houston, Texas. We were actually founded in 1984. We started out as graphics technology experts and have been doing that for over 30 years. We've initially we're one of the promoters of the CGM standard, initially providing a free CGM and TIFF viewer. We're a member of the CGM Open Foundation. Our mission or purpose is to develop 2D and 3D technical illustration software conversions and viewing solutions based on open file formats like CGM and SVG and other graphic formats. We were the developer of the first HTML5 CGM viewer that eliminated the need for CGM plugins. We also introduced the first CGM profile to assist in the standardization of this file format in S1000D. Larson Software currently participates in S1000D Graphics and Multimedia Working Group. And that all said, we'll turn it over to Dave Manick now for the main part of our presentation. I'll be joining you again at the end for the Q&A.
Thank you, Don. Welcome, everybody. Pleased you could join us today. I'd also like to quickly introduce Mark Meyer. Mark is the VP of Software Development at Larson, and Mark will be helping out with the questions if required at the end, because we'd be covering some things really around our VizEx View 3D technology today, which is more of a development tool. So as I said, welcome everybody. Let's get started. The webinar will provide an overview of 3D interactive technical illustrations, their creation and their integration with XML or HTML. So we're going to demonstrate, do some live demonstrations, the import of 3D CAD data, the repurposing of that CAD data, animation of 3D assets or components, the integration of that with textual information. So kind of a full interactive manual type illustration, and the viewing of the completed illustration in that environment. So that's what we'll be demonstrating live today. To enable us to do that, we'll be showing two pieces of technology developed by Larson, which is VizEx Edit 3D, which is our creation software for 3D technical illustrations. And then we'll also be showing our viewer technology for viewing those illustrations in different environments, mainly obviously in a browser, web browser environment. So what are the types of illustrations that we could create in 3D? And it's pretty much everything we would create in 2D. So exploded spare part type illustrations, procedural illustrations, which could be assembly, disassembly, scheduled and unscheduled maintenance and repair and overhaul, and then operational and instructional illustrations, and then some specialist illustrations as well, like ghosted or cutaway or functional type illustrations. So everything we can do in 2D we can now really do in 3D as well. So here are some of the file formats that we're going to be looking at today. And the source of the illustration would usually be for now CAD data. So that could be an IGES or a STEP file. What we would do then is import it into our software, VizEx Edit 3D, and we would save as a VX 3D file, which is our own format where you can archive files to save them, go back to them, revise them, etc. We would then export the files out as a GLTF or GLB to go into our publication or IETM, where we would integrate with the XML or HTML. So we'll be showing that process as part of the demonstration. So this is kind of the workflow we'll be looking at. So importing of that STEP or IGES file, the creation of the 3D technical illustration with interactivity, and then once you've created it, we won't be showing this today, but you would be able to take that GLTF or GLB into your CSDB and store it as you would a CGM or SVG, and also stored alongside your data modules. And then the output would then go into your IETM by whatever process you use or how you build that data. And in the IETM, you would be using VizEx View 3D or another GLTF GLB viewer to view that information in your finished IETM. So you might ask yourself, why not just use a CAD system to create these technical illustrations? You certainly could export the model into a CAD viewer and view them, but there are some specific requirements usually for technical illustrations that are not really considered in CAD systems. And plus, it could be over the top or just too difficult to use for many people when they don't need all the functionality of the CAD system. So it would really benefit the illustrator or technical writer by having something more specific to what they want to achieve. So good data exchange options, easy manipulation of the 3D model, isolate the assemblies, explode them, perhaps even generate 2D graphics from them if that's still the way you want to go. But more importantly for us today is easily create 3D technical illustrations by adding value with, for example, animations or annotations. So the major file formats from the CAD side or the open formats would be IGES or STEP, probably more likely to be STEP. And really all the major CAD systems will support these file formats. There is a possibility you could use native file formats as well, but that would be more problematic from an import point of view because we'd have to support lots of different native file formats. So STEP and IGES, especially STEP, is a really good alternative. So let's look at an overview of how we're going to create these 3D technical illustrations. So I said we would import the STEP or IGES file, then probably save as a VX3D file, which is our own native format. So why we'd want to do that is usually because if you want to actually save it in a state that you could go back to and revise, then we couldn't really do that with the engineering data. So we created this file format so you could save the changes to a file and then revisit them, either to revise them or to finish them off. And VizEx Edit 3D provides full control over the model, so we can explode it. So if you were creating a spare parts type illustration, we can animate it, the 3D model. So if you're creating procedural or operational type illustrations, and then we can use at the end VizEx View 3D, our software for viewing those files within that web or web browser environment. In other words, in your IETM. And to do that, we would export as a GLTF or GLB file. So I've experienced over the last perhaps few webinars that we've done, not a misunderstanding, but I think it'd be better to explain what hotspots are in the 3D world. So what's the major difference between 3D and 2D data and hotspots? So in 2D, probably a lot of you are familiar, perhaps already, with adding a hotspot to an illustration in 2D, which we could also determine as metadata. This would usually be at the moment be on a call out, perhaps for an illustrated parts illustration, so we can have an interactivity between the text and the graphic. So we have to add that to either a CGM or an SVG file for that to work. In a 3D CAD file, it's a bit different because the data structure is already built in to the file. So as a result, a component is kind of interactive by default because it has its own attributes. So we don't really need to add hotspots to that component. And the additional benefit is that with the 3D model tree that would usually come with the CAD file as well, is that we can see where its hierarchy is in the overall platform or system. And we could see assemblies and sub-assemblies. So we're getting a lot more information to work with the 3D off the bat without having to kind of create that by, in 2D, you might have to group things together and so forth. And the added benefit as well is that when we're doing an animation in 3D, that we can use that structure to move components, move assemblies, control their visibility, rotate them in space, and then we could record and capture that and play that back in a GLTF file because that's able to contain animation data. So one of the questions we get to ask is why did we support GLTF and GLB? They are one and the same thing, by the way. Just the GLB is like a binary file, so everything is in one file. We chose it really because it's an open format. It's an ISO standard, and you can get a really good data inside the file that's applicable to technical publications or technical illustrations. Plus, there's no plugin required. So in the IETM, there is no plugin, so you don't have to install another plugin to actually view the graphic. It's very efficient. It supports the inclusion of animations, and it also allows the creation of file format extensions. So for some of the things that we've done in our our authoring tool, VizEx Edit 3D, we've created an extension in the format that allows us to, say, do an annotation, for instance, like an annotation we'll see in a 2D file. So just going over to S1000D a minute, then this might show that if selected for S1000D, this file format will probably need a profile as CGM or SVG does to actually standardize it in some way. It also optimizes the size of the file, and it's really widely supported by the major software vendors like Microsoft and Adobe. So just to touch on S1000D for a minute, I know issue 6 has just been released, but it's not changed really the guidance on 3D at the moment. That will come in the future. There is no file format specified, and there's really just guidelines, to be honest, at the moment. That will change. The working group will be looking at 3D and is looking at 3D, and it will be introduced in the future, or it will be revised in the future. What spec, I don't know. It could be in 6 as an incremental update, or it could be 7. I can't really say that at the moment. So let's go to the demo. Let's go through some of the things I was talking about live so you can see how we put these things together. So I'm going to go to VizEx Edit 3D. Hopefully you can see that on screen. Let me just check we can do. Yeah. Okay, so first off, I'm going to import a step file. This is just a standard one that we use just for demo purposes. It's not a large file, but it just gives us, it's a good demonstration piece so you can see how we can do things pretty quickly. But you can see when I move over, when I was talking about interactivity, then you can always see that these parts are active. And if I click on one of them, then it highlights in the model tree over here. So you can already see that there is some interaction between, in this case, this is the model tree and the model itself. So these have attributes and properties. So we can see here under the properties menu in VizEx Edit 3D that this is it's got a name which come over from the card, and also an ID and its rotation and some other things that perhaps we don't really need to know about. But perhaps the name, in this case, I know this name when I come through into our viewer that it's kind of a tooltip. So I can make a change to this and save the name, get rid of the 22, and I've now give it the name just bevel gear. And I'm going to export this as a GLB file. So I'm just going to overwrite the one that's already here. And say OK. And then what I can do from here is I can give you the first glimpse of our viewer. And I can open that up. So let me just open that particular file, which I think was this one. So this is our viewing environment, VizEx View 3D, and I'm just using it here as like kind of a standalone viewer. So as I move over, you can see now it just says bevel gear, the 22 has gone away. So I can zoom in on this, I can move it around in the space. I don't know what the performance will be like for yourselves on the internet, but you can see that it's pretty quick, certainly for me, moving the model around in the viewer. So this is the GLB file, and this is VizEx View 3D, and I just opened that file up to view it. So let's just go back to VizEx Edit 3D. So I did mention I could save, so I could, instead of import or export, I can save as, this is a VizEx VX3D file. So this means I could reopen it in the future in a particular state and keep on working on it. So I'm going to save this. Okay. And now I'm going to do the animation. So this is where we really begin to do the kind of interactivity that will eventually go into the IATM. So how do I go about that? So if I go to animation up here and create, I'm going to create step 1. This would be of my procedure. Click OK. And you'll notice the window changes. So now at the bottom, I've got this timeline. So if I click this, say, coupling, and I now move it, if you notice that it goes light blue means that's the direction I'm going to move it in, and apply, then now I've moved that away from the main assembly, and it's added to the timeline here. So if I just move this back, I can play that just to kind of reinforce that that's what's actually happened. So that's step 1. You can see it again, step 1 up here. So I'm going to save and close that and create again, and this time I'm going to create step 2. The reason I create these steps individually is that it gives you an ID, or it will give us an ID later on to link to these different steps that I'm creating, so we can step through the procedure. So the next thing we're going to do is just remove the bolts. So I can select more than one item at a time, and you can see that they stack up down here. And again, I can move these away from the main assembly and apply that. Now, I also then want to move this large bevel gear, so I'm going to just fade these away so I've got some space to put them into. So again, shift, and then I'm going to fade. So you can see we've got different things we can do here, like rotate or change the color and highlight but I'm just going to fade them in this case and apply. So just to check that, it's actually, they've disappeared because it's gone to the end of that animation. But if I just click now, they should fade. Okay, that's good. So I'm going to save and close. So that was step 2. Again, I'm going to create step 3. This name is important as well, just to emphasize that, because that's what we're going to use to link to the text later on. So click step 3. Obviously, the bolts aren't here because they've now been faded away. I'm going to move the bevel gear into this area and apply it. Okay, I'm happy with that, and save and close. And then step 4 is here. So this time I'm going to do something a bit different. I'm going to change the camera angle. So I'm going to transform the whole thing, select camera, and I'm going to rotate it about the Z axis, which is the vertical, 180 degrees, and I can preview that, so it just kind of switches it round and apply. So if I just go, you can see now that that's what it would do in the animation. So let's save and close that. So I've now got those 4 steps recorded. If I go to manage within VizEx Edit 3D, I could have done this before now, but you can see here's the steps that I've created, and now I could say play all, and it should actually go through those steps as I created them. And obviously I could create more steps depending on what the item is. So, excuse me. So what I'm going to do now is I'm going to export this as a GLB file because I just want to test it in my viewer environment. So I'm just going to overwrite this anime new. And this time I got this option to export the animations. So yeah, I definitely want those. And I'm going back into the viewer, but the standalone viewer. So let me just refresh this, and I'm going to bring in that new illustration with the animations. So you'll hopefully notice that there's a new thing actually appeared here, animations in the viewer. And that means now I can say step 1. So I can play these back. It should fade, and then 3, and then 4 will change the angle. So this is obviously 3D, so I can still move it around, but I'm just playing back those animations that I did. This is all well and good, but it doesn't really give me any connection to trigger these steps with text. So that will be our next phase, is how do we then link that to the text, say for an ITM, where we have the instruction as well as the step itself. Okay, so let's go back to the slides. So how do we integrate that GLB or GLTF file with this textual information on this side? So I'll apologize up front if this might be it's fairly technical, but it should, hopefully I explain it in a way that you understand how we would do the linking between the two. So the 3D illustration has been authored and exported as a GLB file, and the GLB now contains all that information in the case of the steps with IDs, because we created step 1, step 2, and you could see that we could play those individually back in the viewer. And the same would apply if you were going into a parts list, because each component would have its own ID, which would by default. So we could also link that to say a parts list. So what do we need to do to enable this? So we need the code. We need some code to enable the position and size of the 3D viewer itself. The IDs are we need to recognize those within that file as procedural steps. And we need in the textual side an interactive button to trigger that particular animation step. So to do that, we're going to need some technologies to do it. Some we've already looked at. So VizEx View 3D is our 3D viewer. So that enables us to see the animations in the 3D file, the GLB file. So the other technology that we use to create our VizEx View 3D is something called 3JS, which is a JavaScript library. It's an open source technology, and we use that to create our VizEx View 3D viewer. And then WebGL is quite pervasive out there. Most computers and systems support it, and that is the background technology for viewing 3D and 2D graphics without a plugin. And they're also, WebGL is also optimized to work with graphics cards, so you get a really good fast rendering of the file itself. So to define the 3D viewer position and size, we would use what we call the canvas link. So this would actually define the width and the height of the viewer, where it's positioned on the page, and so forth. So it's quite straightforward to create this on the left-hand side, the actual viewer window itself. We then need to define the textual side. So this would be, in this case, is the HTML. So we have here the different steps, which are buttons. So we can see here that on this button, you would play the step, in this case, step 1. So I've just made it a bit bigger here. So we click on the button, and it's going to play step 1 of the GLB file. So these are all the other, I only created 4 steps, but you can see that in the total there's 8 here. The background color is just the color of the button, and obviously this is the text itself for the instruction. The GLT and the GLB file actually contains this information, and this is where the link takes place. So just going back to the previous slide, you saw here that we had the step 1, which was what we created in the VizEx Edit 3D, was our identifier, and that ties then to the animation step 1. So when we click on that button, that's what animation it's going to play in the GLB file. So this is the GLB file, the data inside that file. So it's a bit kind of like CGM linking to the XML or HTML data to trigger the hotspot. Very, very similar. What we also need to do is we need to load our VizEx View 3D library, which is our viewer library. And this gives you really functionality that you saw earlier on about playing animations and things like that, rotating the model and really utilizing that information effectively within the viewer. So this particular line just loads that. And this here is a link to our documentation on our VizEx View 3D API or library, where you can see all the functions that it has, which we'll discuss a few more of those functions in a minute. So one of the functions of the viewer library is to load the actual file itself, which obviously we're going to need. So load GLTF means that now it's looking to load this particular illustration into the viewer. So pretty straightforward, just like a file that we're going to load. And then this function here, again from our VizEx View 3D library, is it's going to list a look inside that file to see what all the animations are inside the file. So obviously we need to capture that so we could do each step and link to each step. So let me just go, I'll just show you, don't get phased by this file, but this is the actual whole of the HTML file that we're going to be looking at in a minute. And I've tried to break it down so you can see here, this is the code for where we position the viewer and the size of the viewer, which is done by this canvas tag. Then we're defining the place in the HTML for the step text. So here's the actual, so we can see here step 1 again. So that's going to, when we trigger that, the button that we have is going to play step 1 in the GLB file, and so on. This is the one where we're loading the library itself. So that was number 4. Number 5 is where we load the illustration, so we can see the GLB illustration. And then we get the list of the animations here. So just to give you some idea, we can see, I think in code-wise, there's about 200 odd lines of code for this particular demonstration. So let's go to the to that file and let's play that back. So here we have the illustration, and now we have the steps on this side. So if I click on the step, this will repeat what I did in the demo earlier. These first 4 steps, it will fade it away, and then step 3 will move the bevel gear out. Step 4 will rotate it. Step 5 is going to remove the gearbox casing. That was actually an assembly, so that was all moved in one. Then we remove the pin. So VizEx Edit 3D also allows us to remove something on a perpendicular, not necessarily on an isometric plane. And then step 8 gives us a caution for that particular step. So he wants to highlight something on here. So this is kind of one of the extensions I was talking about, where we can apply a leader line, something more like you would see in a technical illustration, or a warning or a caution. These buttons here just allow us to reset this here. The other example I have is more of an illustrated parts data. So in fact, this is probably more straightforward to actually create than the procedure, because each component already has that property, that ID, automatically. So you can see the body, we just need to link the IDs here to create the table. So we got you can see, hopefully it's quite faint, that we can move over and the table highlights, and in the opposite direction as well. It's, again, you might be able to see the body highlights. And then we could have different sheets for this. It's all obviously 3D. And this table will work with it as well. Okay, so hopefully that gives you a flavor how we might actually go from the illustration to integrate it with the IETM or the browser. So in summary, I think hopefully you see that it's quite straightforward to create this type of illustration, even with the animation. You can see how we can manipulate the model, animate the model, and then save as a GLTF or GLB file to be viewed in our viewer, or another GLTF or GLB viewer, and then integrate that with the XML or HTML for your completed IETM for the customer. And it's got full interactivity, and that is really a big benefit, really, of the 3D. Okay, so the two technologies you've seen today, you can easily evaluate them if you just drop me an email, or you can even go to our website and request them as well. But you can evaluate both technologies, the viewer and also the authoring tool, VizEx Edit 3D. So don't hesitate to contact us if you would like to do an evaluation. and we're open to questions, and I think we do have some. So if Mark and Don want to rejoin me, then we perhaps go through these. I'm just looking at the first one. So what content from the CAD being retained on the import? I'm not quite clear what that means. Don, have you?
Well, I guess I could say that the structure of the hierarchy and structure of the CAD data is retained. So there is a model tree, and where you have assemblies and parts, and so that is obviously that would be retained on import. The geometry of the all the shapes. The visualization is also retained, but more importantly, the geometry, so that you can edit it and do all these things with it.
I think that question's just been clarified, Don. What
Okay.
meta information? So obviously we saw the properties, didn't we, of the part name, and also the ID of the part itself. So it could be a part number. So I would say it really depends on the CAD file. So we would really retain whatever's in that file, and if there's something that's in the file that's missing and we're not showing, we can obviously look to import that. So from a meta information. So usually we see description and part name. It really depends also what's in the CAD file itself. So it would need to be present in it for us to display it. Sorry, Dan.
Okay. Yeah.
Is there a
That's
limit to the CAD model size that VX3D can support? We've had this before, haven't we, Dan? Perhaps you want to.
Yeah, and that is hard to define, because it's one of the factors. One of the factors is number one is the size of your RAM and the speed of your computer. That's a factor. The more RAM, the better. We usually recommend 32 meg of RAM, minimum 16 meg of RAM. There's some other factors too. We found that data that's exported directly from the CAD system, let's say SolidWorks, data exported directly from SolidWorks, performs better importing than, let's say, if it's come from another system and then gone through one of these translators to put it in the step. It can vary the speed. There's a thing that goes on. It's called healing of the geometry. The geometry is not complete. So when they're being imported, if it's got to kick into this healing for the parts, that can dramatically slow it down. 5 or 10 times speed. So they can take quite a long time to import, but it's really hard to define, and it's just I think it's good to know where your CAD data is coming from, what CAD system, and that'll help us determine or define that.
Yeah, that's good. Yeah, there's a lot of dependencies, really, isn't there? But we are working continuously on the import of data and trying to optimize that as much as possible.
Yes.
Is there an option to vary the quality of output if I was to export to CGM? I think there is some settings, isn't there, Don, to do that?
Yeah, there's a quality setting on the, well, it depends on too which format you're going to, whether you're going to CGM or SVG, which is vector data, as opposed to exporting to a JPEG, let's say. We see sometimes where a JPEG image of the model is useful for bringing that over to 2D. So if you export to CGM or SVG, there's a quality setting. We can output as a simple line art, full line art, all polylines, or we can import the curves and stuff as higher level elements. and the higher level, higher quality takes more time, but it's easier to edit. So there's some control there.
Yes. Okay, thank you, Don. Somebody noticed that the explosion tab if you did notice, it was there. This is a new feature for the next release of the software. We're just going through some final testing of that at the moment, but that will be in the next release of the software. So, as I said, we're just doing some final testing on that until we officially release it. So we will have an animate tab, which is animation tab, but the explosion tab will allow you to create multiple explosions of a model, save those in different views. And we've also improved the auto explosion as well, where you can actually explode it down a preferred axis, which should make exploding models a lot quicker and easier. So that will be in the next release. Okay. Do we have the ability to export as 3D PDF? The quick answer is no. We did look at 3D PDF, but we decided against it really because we wanted to work within the world of IETMs, where traditionally you would have some kind of graphics viewer to actually view it as part of the overall publication. And I'm not sure 3D PDF would allow us to do that very easily. So, and we are working with vendors such as Raytheon and their Eagle Vision software for IETM software, where they've integrated it in quite easily. So the short answer is no. It's something we might look at in the future if there is a demand for that. Okay. So does VizEx View 3D also work offline with locally stored models or online or both? Mark, do you want to?
Sure thing.
Answer
The answer to that is both. We currently have an internal toolbar that uses a little bit of formatting that we get from Google online, but we bring those files in if necessary, and you can run it offline. Or if you don't use the internal toolbar at all, then it's good to go.
Okay. Thank you, Mark. It's also probably worth saying that you would also work on the mobile devices, iPads and Android devices, Mark?
Right.
The viewer, yeah.
Yeah.
Don, I don't know if you understand this. Are there any plans to support web GPU in the future?
Yeah, I'm not sure what's meant by that. Now, I suspect what they're referring to is GPU acceleration. And it does, the web CGM API that the viewer is based on does use the GPU, so it's GPU accelerated. Now, this may be some other standard if you could expand on that a little bit. Is that some other standard or something that I'm not aware of? But if it's just regarding GPU acceleration in the 3D viewer, that is supported, and it's supported even on mobile devices, like on an iPad. It runs just as fast as it does on a desktop, and
yeah, we could do some research into that as well offline.
Yeah, I'll Google that myself and get back with that. The person that posed that question,
and probably the last question, which I'm going to give to you, Dan. when is the next release likely to be released?
Yes, we're shooting for the end of this month or early November. So
okay.
we just trying to work on the stability. That's one of the key things we want to get. That new explosion view is there, but we want to get all the stability. And then we discovered some bugs that have been posed lately on the create reverse animations, and we're just cleaning that up this week. And so we're working really hard. I would really love to get it out to everyone by the end of this month.
Yeah. Yeah, we want to make sure that it's tested thoroughly before we make that next release. It's got some quite a lot of new functions in it. Yeah, and we continue to obviously develop with ideas, a lot of ideas coming from customers and people who evaluate as well. So, we're really happy for your input if you have any, either from an evaluation point of view or from a customer, obviously from a customer point of view. So, thank you everybody for joining us today. That's the end of the questions. I hope you found it interesting. We have recorded the session, and we will be posting that later today onto YouTube. You should get an email tomorrow with the link if you want to hand it off to any of your colleagues. And also the slides, there'll be a link to the slides as well. Like I said, if you want to evaluate, please contact us. We'll be happy to help you out with that. So thank you for everybody for joining us today. And we have another webinar probably in October, which we'll be releasing information on soon. Thank you again. Have a good day, everybody.